The point-in-time simulation is measuring how many light levels fall onto the surface at a given moment in time. In contrast, the climate-based simulation measures each grid point based on certain threshold of light levels, and each grid point results are then measured into the percentage of time that grid points are illuminated above certain lux level by the daylighting. Therefore, the end result is the percentage of the time. This may sound complicated. I will go over this again on the next slide. Daylight autonomy shows the very basic process of this daylight simulation process. When we look at the result of the daylight autonomy, at a given point, it is telling us that percentage of the occupied hours at these particular points is above certain illuminance threshold. In this case, we're using a 300 lux as the lower threshold. For example, at this point, 58% of time at this point is above 300 lux. This basically shows us the representation of each of those points and what percentage of time they are above that threshold. By looking at this legend, you can determine that the reddish portion that is close to the window are daylit 100% of the time during the work hours, while the space represented as a color of purple is not daylighted at all throughout the work hours. And you can see the gradient of changes happening between those extreme surfaces represented as a gradient of color. If we take that one dimension above and say that percentage of all of those points, that space is above 50%, now we get a single number for that entire space's spatial daylight time. Giving this single number summarizes each point's amount of time above the illumination threshold spatially throughout the whole room. For example, by setting the threshold at 50%, I can block out the portion that each point's time that is over 300 lux is more than 50% of entire working hours and represented as a green zone in the map visually. And if you look here, you can see that this area which represent the points where the more than 50% of hours is achieving more than 300 lux is only 18.8% out of the entire room's area. Therefore, this single number, which is 18.8% in this case, conveniently describe the quality of the room in terms of daylighting. The more this single number is, the more area that this room is daylit more than 50% based on the spatial daylit autonomy. There is also a more detailed way of calculating the level of daylighting called continuous daylight autonomy. This gives partial credit to the supplementary light levels, differentiating the contribution percentage for the resulting number. But we will not address this for this class. Lastly, using the daylight illuminance introduces the upper threshold as well. The UDI shows the percentage of area inside the space that meets the minimum daylight illuminance level for a specified fraction of working hours per year, usually between the lower threshold of 300 lux and also the high threshold of 3000 lux for at least 50% of the working hour. So having the high threshold is the only difference. And as you notice, the only difference from spatial daylight autonomy is that it blocked out some portion of the overly lit perimeter zone from the useful daylit zone. Therefore, this number, which describes the percentage of area which is over 50% of working hour with the illuminance level between 300 and 3000 lux, is slightly reduced compared to the spatial daylight autonomy value.